Okay, everybody, here's a little graphing practice for you. I have here a little description of a little experiment, I suppose. It could be done in a physics or physical science class. And what we see here is that Tracy wants to see what the relationship is between the drop height and the bounce height for a golf ball. So she decides that she will drop the golf ball from several different heights, and using a slow motion video, she will measure the bounce height for each trial. So she'll have like a meter stick set up, and or actually probably a couple of them. Probably tape those to the wall, and then she can drop the golf ball from a certain height, and then she'll be able to use the video to measure exactly where that golf ball bounces to. Using a little slow motion, pause the video and be able to see the meter stick and the golf ball and stuff, and she'll be able to make that work. So she's going to collect the data. All right. Now the question becomes, hey, what is the manipulative variable in this experiment? So what is the manipulative? Well, remember, that's like asking which one is she changing. So she decides, let's see, she will drop the golf ball from several different heights. So what does that mean then? Well, I hope that you're thinking what I'm thinking, and that the manipulative is the drop height. So manipulative would be drop height, and therefore the bounce height is going to respond to the height from which the ball is dropped. I hope that makes sense. So again, she's manipulating the drop height, she's manipulating that, and then the bounce height is what she's going to measure that's going to respond to the change in drop height. So next we'll look at how to set up the graph and the data. So here's the data he has. So this data table that she set up here, so she has the drop height there all listed, and this is all measured in centimeters, as you can see from the table, and the bounce height also in centimeters. So now that you know that the drop height, we said, was the, oh shoot, what did we say? I don't even know. We said it was the manipulative, which I hope you remember goes on the x-axis. Oops, x. And the bounce height is the responsive, and so then it goes on the y. So we can then, on our graph, wait, oh boy, let's see if I can make this work. We will put the drop height down here, drop down here, measured in centimeters. Remember, always have your unit of measure. And then the bounce is going to be on the vertical axis, and that's also measured in centimeters. And now we got to figure out how do we do our intervals, knowing that we have only so many boxes available. So in this case, I don't know, I think I counted like 19 or 20 along here for the drop, and then for the bounce, I think I had another maybe 19 or 20. So if we need to get to 102 on the bounce axis, and I've got about 20 boxes here, I guess I can probably go with, oh wait a second, I wonder if I can move this a little bit. Can I move that? Oh man, I want to move that. What the? That's not working. Well, never mind that. What the? This is no good. I want to move this thing. Well, maybe it won't let me. Try one more time. Oh, it's moving the whole thing. It's not what I wanted to move. I want to move this. That's not it. Are you kidding me? This is some kind of a sick joke. Well, hold on. I got one more chance. Aha! I moved it. Yeah. Oh, okay. That's good right there. Okay. I think that's where it just was. I don't even know. All right. Anyway, now that I've wasted an entire minute. All right, we got to figure out our interval, what we can do for an interval. So if we know we have about 20 boxes here, and I need to get up to 102, then let's see, if we just take 100 divided by 20 boxes, then that means I can go by intervals of 5. Hopefully you see that. Intervals of 5. So let me erase that. And I'll start putting my intervals on there. And, oh boy, hopefully I can do this. I'm going to go by 5s, but I'm going to actually write only the 10s down. So 5, 10, 15, and then 20 here. 25, and then 30. 35, and then 40. 45, and then 50. Oh boy. And then 55 and 60. 65 and 70. 75 and 80, 85 and 90. Oh no, look at that. It's going to be, oh boy. And then 95 and then 100. Oh no. And then I got to go a little bit above that with my last data point. Son of a gun. All right, now for the drop axis, let's see, I got to get up to 150. So there's no way I can go by 5s then and go up to 150. I would need 30 boxes, and I don't have 30 boxes. So I could go by 10s, but I'm only going to write down the 20s. So it'd be 10, 20 here. So 20, 30, 40, 50, 60, 70, 80, 90, 100, then 110, 120. Oops, might need the 1. Oh no, that's terrible. You'll be fine. And then 130, 140, and then 150, 160. I don't even know what I'm doing right now. All right, so there we go, 160. That's plenty. Okay, now I can plot my points. Oh boy, that's going to take a minute here. Oh, sheesh. All right, so I need 5, 3. 5 would be, if that's 10, then that's 5. 5 and 3 would be about maybe here. And then 10, 7. 10, 7 would be about here, maybe. And then 15, 9 would be about maybe here. Oh, that's a little too high, but it's okay. And then 25, 14 would be about right here, maybe. Then, see, 50, 35, 50 here, and then 35 right about there. And where am I? 75, 46. 75 would be right about here. 46, about right there. And what do we got next? 100 and then 62, 100 and then 62, and then let's see, 150, and oh boy, 150, and then oh geez, 102. Oh boy, right about there. Okay, so here is our data all plotted, and now we got to draw a best fit. And so I'm gonna lay a ruler on my iPad screen because I can. And I don't know exactly if this is going to work right or look right. I may have to undo this and try this a couple times because, yeah. Oh, I was going to change the color. Oh, man. I was going to make it a red line. Oh, well, it's good enough. It's not perfectly straight, but it looks like it's following the data. Now, again, all the data is not on the line, and that's normal. Some of the data points are perfectly on the line, and that's great, but not all of them will be most of the time when you're collecting data like this. However, I want to cover a couple different things here. You got to remember, this line now that has a constant positive slope means that this is directly proportional data, right? So this is directly proportional. Oh boy, proportional. There we go. So this is directly proportional, and if asked if this is showing that there's a relationship, then you would say yes, there is a relationship, okay? And you would say that there's a relationship because the line is going up here. So if you think about this, that means as your drop height is increasing, as you continue to raise the drop height, what's happening? The bounce height is getting bigger and bigger. That means there is a relationship. Most definitely a relationship. And that relationship is directly proportional. Okay? Because it is a constant slope, linear graph, straight line. All right, well, last thing. 2 questions. One is going to be this. I want to know if we had dropped the golf ball, that's the thing. If we had dropped the golf ball from 40 centimeters, where would you expect the bounce to be? How high would you expect the bounce if you drop it from 40 centimeters? So if you're looking at 40 centimeters, okay, of drop. So we go up to then the line, and then we hang a left at the best. Oh no, what the heck just happened? Did something just move? Holy crap. So now we are moving. Oh, come on, you. Moving across until we get to there. Oh my gosh, it's terrible. So I did this. I started at 40. I went up. That's 40 centimeters for the drop. Went up to the best fit line. Took a left turn. And that's telling me that I would expect the bounce height to be between 25 and 30 centimeters. So it looks like it might be around 27, 28, something like that. So that would be then my answer. I would expect a bounce of about 27 or 27 to 28 centimeters if I were to drop the golf ball from 40 centimeters. Now, what if I were to ask this question? What if I had a bounce height of, I don't know, maybe 80? If it bounced to 80 centimeters, then what would be the drop height required for that? Okay, so if I have a bounce of 80 centimeters, I want to know how high does it have to be dropped from to make that happen. So I start at the bounce of 80, and I walk it over to my maybe best fit, and I hit my best fit. Then I drop it down from my best fit down to the drop, which apparently is about 120 centimeters. So, I hope you're following along with this. If my bounce height was 80 centimeters, then it would have to be dropped from 120 centimeters to make that happen, based on my best fit line. If I dropped the ball from 40 centimeters, that would give me a bounce height of 27 to 28 centimeters. So that's basic graph reading, being able to go from one variable to the other using the best fit, being able to start at one variable and go to the other one using the best fit. So hopefully that helps. We'll see you later.